Hey guys, today we're going to be talking about integration by parts. So we can see the basic formula written right here. And if you're familiar with U-Substitution, this is a little similar, but this can help solve a little more complex integrals. So let's start with a sample problem. So here, if we look at this integral, it's going to be a little hard to integrate this without any sort of method to help simplify it. We can't try normal integration because there are two different terms with x in them, and you can't really unite them. And you can't do u-sub because if you set u equal to 6x, the du is not going to cancel out this x right here. So a way to fix this is integration by parts. Over here you can see integration by parts splits this integral into two separate parts and expands them into a few terms that are easier to integrate and calculate. So let's do that with this. Alright, so as you can see here, we've split this into two separate parts, x and e to the 6x dx. We set this one equal to u, which is right here, and we set this one equal to dv. Now in the final equation, we're going to need u, v, and du. And right now we only have u and dv. So we're going to have to make this we're going to have to find v from dv, and we're going to have to find du from u. So what we did here was we took the derivative of u with respect to x, and that would equal 1, but we multiplied the dx over to the other side, so we could just isolate du. And so then du would equal dx. And then what we did for dv was we integrated it, and we got v equals 1 over 6 e to the 6x. Now you might be wondering, why is there no c here? Since we took the indefinite integral, there's usually a constant after it. Well, you'll see later on as we go through the problem, the c would disappear because you subtract it from itself when you plug it into the integral and to this term right here. So now that we have these components, we can easily plug them into this equation. So after plugging these in, this is what we get. And the bounds that I use here are the same that we had in the initial integral. So now that we have much simpler terms, we can just evaluate this and we can integrate this without any need for some outside method. However, we're going to hold off on this, and we're going to use this one first because it'd be easier to put them together with the same bounds. So now you can see what I meant by having the similar bounds, making it easier to put together. So if we expand these terms, this is what we get. And we can simplify this to get our final answer. So with the help of integration by parts, we were able to expand this integral and make it a more simpler calculation to get our final answer. And with that, we conclude our lesson on integration by parts. Thanks for watching.